All right. Good morning, everyone. Welcome back to Comp 2450. So I've run the auto configuration wizard again on OBS, and I did it upstairs in my office too. And I was like connected to the, oh my gosh, this is a super digression immediately upon entering class today. I was connected to the primary ingest server on YouTube, which is what it auto configured to a long time ago. And when I was up in my office just now, I did the same thing, and it's like, yes, the primary ingest server is the best one to connect to. But when I did it down here, it says the backup one is the best one to connect to. And last class, the live stream, I think recorded about 4 minutes of actual time. So I'm really happy that I recorded it, and I've replaced the live stream from last class with the recording that I did. Today, now that we're connected to this backup server, it looks like there are some dropped frames, but it's like it's streaming with big green thumbs up. So please let me know after class, because like I said before, I don't watch my own videos. I don't check the streams, so I don't really have any idea that something's going wrong unless I can see here that something's going wrong. But for at least the next little while, I'm just going to record the class while also live streaming to make sure that I have something that I can put up afterwards. All right, with that, let's get started today. What I want to focus on today is spend some time talking a little bit more about dependency injection. So last class, we spent some time thinking about this idea of the dependency inversion principle. I'll remind you of what that means in a moment, but the idea generally is that when we have these different layers of responsibility, they shouldn't know how their dependencies actually work. They should just know what their dependencies can do for them. So they should really only depend on the interface that's exposed by those things. So what can this thing do? I shouldn't have to care how it actually does that, just what can it do for me? And these are behaviors like in the context of persistence, which we're starting to think about now. It saves something. I don't know how it does it. I don't know that it does it to JSON. I don't know whether it uses a real SQL database or not. It's irrelevant. I just know if I pass this thing to this thing that implements this interface, I can get it back later. That's the key thing that I want to be able to do here. This applies to other places in our layers of responsibility. And so I want to do this apply the dependency injection strategy to make some existing code satisfy the dependency inversion principle. And then we're going to take a look at some code that does some persistence with JSON. So what I want you to be able to do by the end of today's lecture is we're going to continue to work on persistent load data and its relationships using a structured text-based format. The very first part of this is about this dependency inversion principle. So this is the D in solid. And again, I will throw Comp 2400 under the bus. You're probably going to be having done L. I know that John has done this, and I think that Dan is maybe getting to this soon if you're in Dan's section. Shrug. Okay, so you'll get to it soon, eventually. And then O you might cover in Comp 2400. If you don't cover it in Comp 2400, we may spend some time talking about it in 2452. We're going to focus on S and D in this course. And what we're thinking about now is the dependency inversion principle. The other thing I want you to be able to do is I want you to be able to persist and load instances of domain model objects to and from a JSON formatted file. I'm going to walk you through some code. I've prepared this code in advance. I'm not going to write it in front of you because it is agonizing to write this code. It is really painful, and it would be really, really painful for me to stand in front of you and type this stuff up because it's basically translating an existing domain model object into a different kind of builder. We'll take a look at it in a bit. It's boring code. It's really, really boring code, but it does what it says on the tin, and that's what I want you to be able to do with this stuff. So first and foremost, the dependency inversion principle. As with last class, the idea here is that we've got these different layers of responsibility. Each layer of responsibility has dependencies. This already exists in the system that we've got. We've got a UI layer of responsibility that has some dependency on implementations of a logic layer. We have this relationship set up already. This UI layer of responsibility should only depend on the interface that's exposed by this logic layer. That is what we want to strive for to satisfy the dependency inversion principle. It shouldn't know how that dependency works. It should only focus on what it can do. So it should only care about what its interface says. And it should not care about how that thing actually works underneath. Part of that is it shouldn't know how to even construct an instance of this dependency. And it shouldn't have the responsibility of constructing instances of this dependency, because it shouldn't need to know how that thing actually works internally. We only really want to know it has this interface, what can it do for me? We're going to use a strategy that's called dependency injection to satisfy the dependency inversion principle. And the way that we are generally going to do that is, at least for our persistence layers, we're going to literally use the interface type in Java. I'll show you this part later, but the important part that we're going to focus on right now is that we're going to change our classes to accept instances of other classes. So the layers that we have, we're going to change our constructors to accept instances of the dependencies rather than having those layers be able to create the instances of the dependencies that they have. We're also going to change our main class here so that it coordinates the construction of all these different classes and passes those dependencies to the classes that we're constructing. So we're taking the responsibility of constructing our dependencies out of the classes that we have right now and moving it to a different spot. Somebody else still has to have this responsibility. Let's take a look at doing this with some of the code that we've got already. I'm going to pop over here to IntelliJ. And the place that I want to focus on right now is in our UI layer here. And this class here that's called battle display. This is the class that we wrote up that had the responsibility of effectively getting inputs. So asking what kinds of things do you want to do here? What move do you want to do right now? And then asking our logic layer implementation to do that stuff for us. So given the input that we've got, I've constructed this domain model. I'm passing it to my logic layer, asking my logic layer to do something. My logic layer then says, maybe I'll do something. It gives me some output possibly, and then I just kind of keep looping until we run to the end of this entire interaction that we've got here. The battle display class here, and before I move on too far, can I just quickly confirm that at the back you can see this okay? Okay, awesome, thank you. Our battle display class has two dependencies. The first dependency that it has here is this, battle. We've got a dependency on our logic layer class. It's got a dependency on our logic layer class. And the other dependency that this class currently has is that it depends on scanner. It depends on scanner for its ability to get input from something. It has some ability to get input from something. The setup of this class right now is a little weird. Right now, the way that we've got battle displays constructor set up is that it takes two instances of trainer, but it doesn't actually keep those trainers around anywhere. So it doesn't really directly depend on any instances of trainer in any clear way. The only thing that it does with these two things that we pass to it is it just passes them directly to the battle that it depends upon, and it constructs that instance of the battle. So our UI is making its own instance of its own dependency and passing the things that that dependency needs to know about. The same thing is happening here with scanner on line 42. We're making an instance of scanner, and we're passing it something that it is then internally using to get input for us from our keyboard, in this case, from system.in. This means that, at least in the context of our constructor here, The battle display class knows how these things work internally. And it's really not its responsibility to know how these things work internally. It should just depend on the interfaces that are provided by these things. And so I'm going to make some changes to our constructor immediately. The constructor is going to now change to, instead of accepting 2 instances of trainer, it's now going to accept an instance of battle, and it's going to accept an instance of scanner. Yeah. The battle display does not have a direct dependency on trainer. So its dependency, the battle class, the logic layer, does have a direct dependency on instances of trainer. But the battle display class really only has a dependency on the battle class itself. So the logic layer that we've got here, yeah. So I'm going to change this constructor. The constructor here is going to be changed such that I'm no longer taking 2 instances of trainer, but instead I'm going to accept an instance of battle and an instance of scanner. I'm going to change my comments here as appropriate. The battle scanner. The thing we're getting input from. I'm going to change my constructor to just use the dependency that's been passed to me. And I've got 2 related problems because there are a couple of other places in this code base where I'm making an instance of this UI class. So there's 2 main methods effectively that I'm using to create instances of this thing. So I've made this change. I now depend only on the interface of the things that I have as a dependency in this layer. And I'm not constructing them internally. I'm not making instances of this stuff. I'm going to click on this 2 related problems. I can see here that I've got 2 different places where I'm doing this. So this is interactive create Pokemon main. Battle display previously took instances of trainers, and now we have to give it the things that it actually depends directly upon. That means that this main method now has to have the responsibility of coordinating all of this stuff for me. So it has to coordinate the dependencies that we've got here. So I'm going to say this. Battle is equal to new battle. It takes a trainer and a trainer. The other thing I'm going to need to do here is to create a new instance of scanner. I'll do Alt-Enter, import the class. And I'm going to change this constructor to accept those 2 things. Okay. So that's one thing fixed. The other one is the same job. So I'm just going to copy and paste this code. All right. So the state that I'm in right now is that battle display, this class that's in my UI layer of responsibility, has 2 direct dependencies, an instance of battle and an instance of scanner. It no longer has the responsibility of constructing those instances itself internally, so it doesn't know anything about how they work. It just knows I'm given this instance, it has this interface, I can ask it to do these things. We've taken the responsibility that this previously had of making those instances, and we've moved that responsibility into the different main methods that we've got here. So start battle main and interactive create Pokemon main. This does the same thing as it did before. We haven't functionally changed anything about how this works. But at this point, we are satisfying this dependency inversion principle. And this is going to let me do something that I think is kind of cool. I'm just so, oh my gosh, I'm overjoyed to be able to show you some of this stuff because I don't know. This is like, I think this is awesome in the dumbest way possible. When Battle Display created its own instance of scanner, it used system.in. It used system.in. I'm going to change this slightly. I'm going to change this to say that when I run this, I've got this battle that's happening between Franklin and Gary. And every time I want to test this, I want to fight. And then tackle. Whoops, 0. And then I want to fight. And then I want to tackle. And then I want to fight. And then I want to tackle. And we've set this up in such a way that we can't actually get past the end of this anymore. But this manual testing was really tedious. And we then decided, okay, automated testing is probably a better way to do this. Have these methods that do all this stuff for us. And I want to be clear that I've explicitly told you, and I will stand by this, we're not testing the UI layer. We are not testing the UI layer. But one of the really cool things about taking the responsibility of constructing this dependency out of that class is that now the scanner that I pass to this thing, I can construct it any way I want. That means some really fun stuff, like I'm going to change the setup here so that each of these Pokemon only have 1 max HP. So basically, whoever gets to go first wins. That's fine. That's going to make this a little bit easier for us. And then I'm going to do this. I'm going to make a new file in the root of my project, and I'm going to call this battle script. It's a plain text file. I'm not doing anything unusual. This is just a plain text file. I'm going to hit play on start battle main. The first thing that I'm going to type in here is fight. So I'm going to type fight as the first line of this file. I'm going to press enter. The next thing that I type in here is 0. I want to select move 0. So I'm going to type in 0 here. I'm going to type in 0 here. The battle is over. Okay, so things have finished. We're all done with the battle because I've changed it so that each Pokemon only has 1 HP here. It ends the battle really, really quickly. But what I can do with this is I can change start battle main here to, instead of using system.in, I can pass it a file. I'm going to say path.of, and I'm going to say battlescript.txt. I'm going to import that class. This is going to say it throws an IO exception. I will just add exception to method signature. Main can throw exception. That's fine. We're going to find this thing that we want to load here. And then I'm going to hit the play button. Oh, no. Thank you. I cannot type. That was really anticlimactic, giant stack trace. I'm going to hit the play button, pretend that didn't happen. I'm going to hit the play button. The battle is over. Okay. So all we've really done here is take the responsibility of create instance of scanner and create instance of battle out of battle display here. But that gives us this really powerful tool of being able to say, you're not making this instance of scanner. You don't know how things are being passed to it. You don't even know what it's using to read from. You don't have to know what it's using to read from, because as far as we're concerned in this battle display class, and I'm going to go back to battle display here. As far as we're concerned in this battle display class, everywhere that we're using this variable keyboard, we're just calling methods on the interface that is provided to us by scanner. We don't have to know how it was constructed. We don't have to know that it's reading from a file or a keyboard or whatever. we're just able to get things from that, and we're able to then proceed with that. And that opens up this cool possibility of effectively saying, I don't want to type all that stuff in every time, so I'm just going to type in what I would have otherwise typed in and hit the play button and just let it run. And I think that's great. I think that's really cool. A small aside, one thing that's going to blow your minds when you get to an operating systems course is that system.in is actually also just a file. It's a different kind of file, but it's actually a file. Yeah. Gosh, I look forward when you get to find that out, but I don't know whether that's going to be in your 3,000 level or 4,000 level. It's not going to be for a while that you see this, but yeah, it's actually a file underneath. Okay, so are there any questions about this so far? Yeah. Can you repeat that just a little bit louder, please? A little bit, yeah. We're reducing the amount of work that one class has to do in that the battle display class here no longer has the responsibility of making those instances of things that it depends upon. We take those instances from somewhere else. So this class has had some responsibility removed from it. And I'm going to say that this really drives home that single responsibility idea. It shouldn't have the responsibility of creating instances of its own dependencies. It satisfies dependency inversion because when we're taking these instances, we don't have to know how it was constructed or what it does internally. We just get to use the interface that's provided by that thing. Yeah. Yeah.
I think if you have like a class that stores sort of like types of collections, and in our constructor, we I guess, assign those collections an implementation. Like, let's say I have a class that holds a set, and then in my constructor, I'm initializing it as a hash map. Does that mean in the main method now we should initialize that hash map and pass it into the constructor of that class, or can we still leave it in the way I initially expected?
So I'm going to open up one of my domain model objects here. I'll go to trainer. And in trainer, what we've got is that it has this set of lists that it has internally. And it doesn't really accept an instance of a list in its constructor, but it does create instances of those sets in its constructor. What you're asking is, should I make the instances of the lists outside of my constructor, I think. Yeah. So in this specific case, it's okay for our domain model objects to have the responsibility of creating those collections. That is part of its responsibility, to know about the data that it internally manages. It also has to have the responsibility of knowing things like, this is a list, so that means that it's a collection that has an order. There's an index 1, an index 2, an index 3, as opposed to a set, which is, it guarantees uniqueness, but there's no particular order that is specified by this thing. When you're making domain model objects, I would really strongly advise, and this kind of sits with this dependency inversion, you use the interface of the type that you want. So don't put array list here anymore, put list. Don't put hash set here, put set. If you need to have a sorted set, for example, there's an interface that extends set that you can say, I need to have order in my set, so I'm going to do sorted set. Within the constructor itself, you can then say, yes, I want to initialize this with an array list specifically, but the rest of my code doesn't know that this is an array list internally. So for domain model objects, I'm going to say, no, you shouldn't pass in those collection instances from somewhere else. It should be responsible for managing its own internal thing. It's more, in our case, the layers of responsibility that we want to separate these things out. Yeah. Yeah.
My question is related to this. I want to know, like, what are the general criteria that determine what kinds of dependencies should really be replaced with dependency injection, and what should be just kept as they are?
So the criteria that I'd say that you would want to have for dependency injection and dependency inversion are more cases like this where we have layers of responsibility that have dependencies on other classes to do things for them. Another indication of this is places where you'd want to be able to change those implementations without this class knowing about it. Domain model objects are almost always not going to have that flexibility. We don't really care to change linked list to array list to some other kind of list externally. It's okay for that domain model object to just know what kind of thing it's using internally for its own data storage. But as we go from the logic layer is like taking input from a keyboard versus taking input from a file here, that's one place where we might want to make that change realistically. As we go to persistence, we're going to provide one specific kind of implementation of persistence, but there's a whole wide world of different kinds of implementations of persistence that we could do. So there's not really a formula, I guess, but generally I'd say that domain model objects aren't going to have this dependency inversion or dependency injection stuff. It's a lot more about the layers of responsibility and the dependencies that we have between those. Yeah. Yes. So the question is about loading data from a file. And I'm going to say that this was meant to be an example of how dependency injection opens up these options for us. I would say that I would not change my code to just load everything from scanner up front. From the perspective of, I still expect somebody to sit here and type stuff in on a keyboard. It's just awfully convenient that I can pass an instance of scanner that's been constructed to read a file instead of standard input here. If you are doing persistence, which we're going to do right away, if you're doing persistence, that's a different problem entirely. The situation that we're in right now is just, we have this thing that already satisfies our dependency inversion principle. This class only depends on the interface exposed by scanner. We can pass it different constructed instances of scanner, and that's really convenient for us to be able to do that, as opposed to, I want to change the way that this works with files. If you wanted to do something with files directly, I'd say that you should probably just have a different class that's responsible for reading a file that has a bunch of prompts, if that was the purpose of what you wanted to accomplish. But this is just a convenient side effect of something that we can do here. Okay, awesome. Yeah.
Well, I'm thinking like here, this dependency injection works because it's first method we're calling. What do we do when we're like a couple layers deep and we're going from whatever method it is, create, and calling a new object that then needs stuff? That's then, do we just like create the method all the way in main and just pass the parameter all the way through, or how does that work?
So I'm going to try to generalize what your question is. I believe what your question is, and change, like, shake your head at me or whatever to say I'm wrong, but I believe your question is basically, what if Battle itself has a dependency on something else? Yeah.
Like in our flow of interaction.
Yeah.
We'll go from like Battle screen, or I don't know, like from this outer layer, for example, like choose thing, and then it goes to a new like Battle screen.
Right.
And so if we're making a, like from in our wider thing, where Battle display isn't our first thing we're starting from.
So if
you get it into Battle display from main,
if
for calling that.
so you're I thank you for clarifying. Now I'm gonna, again, I want to restate your problem to make sure that I get it. What if we go from Battle display to item display, if those are two separate classes? So in that case, I'd say that there is there's going to be cases like that where you have two different classes within the same layer of responsibility that can effectively talk to each other and coordinate with each other. They can create an instance of some other class within that same layer, but then they kind of also then have to have the responsibility of carrying these different dependencies around. Another option is that you try to minimize what this UI layer class does and then just give control back to the main class when it's done as far as it can so that the main class can figure out which is the other UI layer class that it should then construct after that. So from here, if I were to select item and I had a separate class for doing item, I might give control back to main by just returning from start battle. And then allow main to create that other instance of this other display class that it needs to do, and kind of allow main to coordinate that at a higher level for me. Yeah.
Your flow of interaction is less methods calling methods, but more just like groups and switch statements and stuff in main.
Yes, so it kind of moves toward main. I'd argue though that many of your flows of interaction should probably be one class that has methods. There are clear breaks. Yes, there are definitely clear breaks between things, but in a lot of cases, they should be a class that represents that flow of interaction. Yeah. A constructor is a good example of dependency injection, yes, in that we're taking instances of our dependencies. You can also do dependency injection with mutators. So you could change it on the fly, like after doing some part of this battle, we could switch to getting user input as opposed to the file-based thing if we wanted. I can't think of why you would want to do that, but it's something that you could do. Yes, yeah. Yeah.
Just to confirm on this question, main should be the place where all the UI interact with each other.
The main method is effectively the one that I would want to have coordinating the construction of all of our UI classes. And this is because this is where we're going to make all the instances of the dependencies that we have. This is the only one that really knows about all the instances of dependencies that our different layers are going to need. Okay. All right. So we have accomplished dependency inversion, and we've used dependency injection to accomplish that. One of the places that we're going to use dependency injection and dependency inversion is in the form of doing persistence using JSON. For us in this course, all we really need to know about JSON is that it's a text-based format and it's used to represent objects in JavaScript. I believe in Comp 2400, you're starting to do JavaScript either now or after the break. So you're going to see JSON in this other class. But to give you a taste of what this looks like, this is really just key value pairs that represent some data or information and the relationships that we have between those things. So in our code base for this 2450 Pokemon example, we have this class that represents a trainer. A trainer has properties that are attached to it. Trainers have names. Trainers have money. Trainers have items. Trainers have Pokemon. And I've made a small change to our domain model for trainers that trainers can also have friends. I know that this is not canon for us to be friends with our enemy in the main Pokemon game, but let's just ignore that fact for now. We're going to say that we can have other trainers as friends. In JSON, we have curly braces to represent objects. These are keys, but they're effectively the same thing as the name of the variable that we have in our class. Keys can have values. So after the colon, we have some value. We can have arrays. These are lists or arrays. They work the same way that you imagine lists or arrays work in Java. But really importantly, we're not going to write any JSON in this course. We're not going to spend time tediously writing stuff like this out because we have a library to do that for us. There's a convenient library that will do that for us, and the library that I'm going to ask you to use in this course is called JSONP. JSONP, I'm going to show you some documentation about this in just a moment. JSONP uses builders extensively. So we have built our own builders to be able to take user input, the person that's sitting at the keyboard typing stuff in, to slowly build up this object and then eventually build it, make it an instance of it using this build method and calling its constructor. JSONP uses approximately the same idea to do the same thing, but to be able to construct these structures for us so that we can eventually write this out somewhere else. JSON-P, I've given you a link to this in the slides here. I've given you a link to this in the course webpage directly. JSON-P requires that you add some additional dependencies to your POM file so that you have these classes that you can begin to work with. There's some documentation here about getting started with this. So we're going to be focusing on this reading, writing JSON strategy that's described here. And you can kind of see that what this is doing is going through and making these builder objects. These are JSON objects that we're doing. We're making an instance of this builder. And then for each of these different things that we want to put into our JSON object, we specify the key that we want and the value that we want to have. And then eventually we will get a string representation of that. Or at least in the context of what we're doing, we will write this out to a file, or we will read it back from a file. So for you, you're going to have to add these dependencies to your POM file when you are starting to work with this persistence stuff. And what I want to do right now is I want to take a look at some code I've written. Again, this code is kind of tedious to write. It's kind of painful to write. And so I just want to show you the structure of what I've got here to give you a clear example of how you can use this library to take your objects, write them back out to files in a JSON format, and then load them back in again a little bit later. So I'm going to pop over to IntelliJ here. I'm going to close all my tabs. I have put this in a branch that is called completed JSON persistence. This is up on GitLab right now. The branch that I'm going to show you is the one that I will merge into the main branch. So after class today, I'll do that. When you go to the 2450 M1 repository, this is the stuff that you're going to see. It just doesn't look like that right now because it's in this other branch. I'm going to force the checkout. I don't care about that stuff that I've got there. So there's a few different things that I want to show you. The very first thing is that in the battle class, I am now taking an additional dependency in my constructor here. This dependency is an interface that I've specified for my persistence layer. The interface that I've specified for my persistence layer is over here in a new package that I've created for persistence. And this interface has the ability to save a trainer. So given an instance of a trainer, it saves it somehow. We don't need to know how in this class because we don't need to know how our dependency works internally. And the other thing that we can do with this interface is we can load a trainer by name. So I want to be able to get back an instance of trainer from the thing that I have persisted previously. Our battle class takes an instance of this as part of its constructor. This dependency is injected into it. And the place that our battle class is going to do persistence for us is if I go down here to our attack. The place that I want to do persistence in my logic layer here, the point of persistence, the place where I want to do persistence is when the battle's over. So we've gone through the process of taking turns. One of the Pokemon has fainted. All the Pokemon have fainted for one of our trainers. At this point, we'll collect some money. And now I want to save this persistence. I want to save this instance of trainer. I want to save both of these instances of trainer. In my main method, actually, I'm going to go here. In my persistence layer, what I've got is a new class that's called trainer persistence JSON. This implements the interface that's exposed. So we have to satisfy these two things. I need to be able to save a trainer, and I also need to be able to load a trainer by name. To save a trainer, what we are going to do is very coarse-grained persistence. When I'm saving something, I'm just going to load everything from the file. I'm going to update the one thing that has changed, and I'm going to save the whole file again. This is very coarse-grained. This is very, very coarse-grained. This is what I would expect you to do for the kinds of things that you're persisting as well. You don't have to do anything smart like saving just the thing that's changed. Load everything from the file, change that one thing, and put it all back into the file again. So loading the trainers and saving the trainers are kind of one operation here in save trainer. The thing that I want to look at here is this private method that I've got that's called save trainers. The way that this works is I've got this JSON structure, this JSON tool that I'm going to use that's called a JSON writer. The JSON writer takes a file by name. The file that I'm using to write to is something that was injected into this class when I created it. So we'll take a look at the main method in a moment. The file name was passed into this class when it was created. I'm making this new output stream, and then I'm making an object builder. And then for all the trainers that I have in this collection, I have to go through the process of taking all their properties, putting them into a JSON object, and then putting them all into this really big JSON object that represents all the trainers. So overall, what this looks like is I make an object builder, I set properties. So I'm using these keys, the names of the properties that are in the class itself, to put values in there. And then for each of the things that this class is related to, we're going to put different kinds of stuff into this object. A trainer is a class that is composed of Pokemon. A trainer has Pokemon, and it is composed of those Pokemon. We have this composition relationship. That means that an instance of trainer has ownership of the Pokemon that are in it, the instances of Pokemon that are in that class. For us, for persistence, what that means is that when I persist a trainer, I'm also going to fully persist all the Pokemon that are attached to it. It's composed of these object instances. So I got to do the same kind of thing here. Got to loop over all the Pokemon that are in this team, build up this JSON object using this builder strategy that we've already done, take the names of the methods and put them into these property types that I've got here, and then build this thing and add it to the team that I've got here. I'm going to go back up to where I was a moment ago. The other thing that I want to do here is my trainer now has friends. This is a self relationship from the trainer class back to the trainer class, but now we're saying that this is an aggregate relationship. An instance of trainer does not own the friends that it has. It doesn't have ownership of that data. And so when I'm putting my friends in this list, I'm making this a list instead of the whole instance of trainer. This is just a reference to that trainer instance. The reference that I'm putting here is I'm effectively saying that all trainers have a name, and I'm going to have this structure that says these are the names of the other trainers that I am currently friends with. I'm going to go back up one more time here. At the very end of this, what we do is we write this object out to the file. So we're taking the entire structure and we're writing that whole thing out to this file by building this object for us. So I don't have to do all of this manual construction of JSON objects. Yeah.
So should the names be unique so that when we...
In this case, I'm going to say that an additional constraint that we have on our system is that the names are unique things for all trainers in this system. Yeah. Yeah.
What if, like, a friend, for example, doesn't have a unique kind of an identifier that would say this is the author that you're dependent on?
So if your domain model doesn't have a natural identifier that's unique, you may then want to add something that is going to be unique for those things, like an ID field, but it's this class's responsibility to issue those IDs to that. It's not the domain model itself's responsibility to issue those IDs to that thing. And I think that was a question that was asked here last time. Why are we returning instances of that class? And this is where we would change that ID value as we're returning it back to the other class to say this is the ID that I've given to this thing. Yeah. So I write that out. And then once I've written that out, it's going to be put into a file. And I'm going to have that JSON representation of this thing. To do the opposite, so to load things back, then what I'm going to do is basically read all of the trainers that I've got. So I'm going to load them all. So read everything. And to do that, it's kind of the opposite structure. I'm taking these JSON objects and I'm using my own internal builders now to start setting the properties that I've read from this file. And this is a convenient and kind of, again, I think in the dumbest way possible, this is really cool that we've got these builders that can give us input validation on this stuff. But now instead of typing stuff in, I'm getting these values from this JSON file. And that means that I'm also kind of for free, I'm going to put this in quotes, for free, I'm getting input validation on the JSON objects that I'm reading from this disk. So if my parents accidentally open this file in a text editor and they start slamming stuff on the keyboard, hoping for the best, I'm going to be able to know that they have misentered something in the data that I've persisted to this file. To then go through and add our Pokemon here, I do, again, the opposite. I read through the file itself, and I'm going to use a Pokemon builder to help me set all that up. But now that I have these references between the two classes where I only have put their names, now I'm going to have to go through the process of once I've set up all the trainers that I have, I put them into this map object in this method. Now I have to go through and link up all the different trainer friends that I have so that when I pass this domain model object back to my logic layer, it's going to have all of those properties set in it. So what I'm going to do here really quickly is I'm going to go here to trainer for persistence main. And this is our setup. So here's where I'm making an instance of this persistence object. So trainer persistence is the interface that I've got. Trainer persistence JSON, this is the actual implementation. I'm passing it the name of the file that I wanted to write stuff to. These parts here are the same as what I had before when I just set up the dependency injection stuff. And this is still the same thing that I had when I set up the dependency injection stuff. Notice that battle display here does not accept any instance of persistence because it doesn't need to know how this logic layer class battle was constructed in the first place. It's our responsibility here in main to say, I want you to use this specific instance of this persistence thing. And this again means just like I can switch out system.in with the name of a file, in theory, I ought to be able to switch out my JSON instance with a SQL instance or a CSV instance or like my own custom format if I want. When I hit play on this, friend to add should not be null. Okay. Oh my God. Okay. So I didn't actually finish this, I guess. I did finish this. I don't want to debug this in like 2 minutes in front of you. When I put this up, it will work. When I put this up, it will work. However, the important part here is that trainers.json shows up. And this is a mess. This is a mess because it's not meant to be read by us. It's meant to be read by the software that we've written. It's meant to be read by this JSONP library. All right, so at this point, what you should be able to do is you should be able to apply the dependency inversion principle to an existing layered code base. So you should be able to take a class. You should be able to say these are the dependencies that it has, and you should be able to make that constructor accept instances of those dependencies so it no longer has the responsibility of creating instances of its own dependencies. You should also be able to, given some time to take a look at the code that I've got here, take instances of our domain model objects and persist them to JSON formatted file, or alternatively, and in addition to, load them from a JSON formatted file. That's it for today. I hope you all have a good rest of your day, and I will see you all on Friday. Bye, everybody.